This is called a single replacement, where one element takes the place of another element in a compound. So it doesn't matter what type. It could have been a non-metal switches places with a non-metal, or a metal switches places with a metal. But you can only switch the same kind. So it's like you can't go out on a date and, okay, this is going to sound weird, but I don't mean it in a weird way, but it will help you remember, okay? See, like you can't trade in Carson for a girl, okay? On the date, she had to trade Carson in for another boy, okay? Because they are the same. They're like metals, okay?
There has to be a metal?
Yeah, so metals can only trade places with metals, and non-metals can only trade places with non-metals. Okay, you guys didn't get as weirded out from that as I thought you would. But that's great. Okay, so the basic formula for this is like this. We have an X, Y compound, and then there's a Z in the mix there. Whoa! And the Z switches places. So then we get an X with a Z plus a Y. So one gets booted out. Okay? So an example of this is, say we have copper. So we have copper solid. And we add it to silver nitrate. So silver is Ag plus and nitrate is NO3 minus. So we have silver nitrate. Now, this is actually, I'm going to try and dissolve it in water, and when I do, it actually does dissolve, so it's aqueous. So when we get into these types of questions, if it can dissolve in water, you write it as aqueous. If it can't dissolve in water, you write it as a solid.
So if you don't, it gets figured out then?
Yes, exactly. So you need to use your solubility charts when you're doing these types of questions. So make sure those are out as we go through. Now, so let's actually, I'll put it together. So here's some copper solid, and here's some silver nitrate. Okay. Nothing really, oh, it actually does start pretty quickly. Okay, if, well actually I'll let it sit for a minute and then I'll pass it around. You can see a lot faster. So what happens, let's look, which ones are the same? So like if we're looking at metals and metals or non-metals and non-metals.
Copper, silver.
Yeah, so copper is a metal and silver is a metal. And then we have that anion there too. So the copper and silver are going to switch places. Okay? So we say they're going to switch. Now when they switch, we need to make sure that we look at what are the ions to do the switch. So now,
Did it say what the copper was?
which, pardon?
Copper is 2 different.
Exactly, very good question. So take out your charts, and on the copper, you pick, unless it specifies, you pick the first one that's, so from the top down,
2 plus.
so 2 plus. The reason is because 2 plus is the more common one. And so if it doesn't tell you, you assume the more common one. So that was a great question. So now the silver is written by itself. When silver is by itself at room temperature, what is it? Solid. Take off my gloves. And then we add copper 2 plus, so we have the Cu2 plus and NO3 minus. So our compound is, when we crisscross, will be, I'm running out of room. I'm just going to erase it and move it all over a little bit. Actually, I wonder if I can do, oh, there we go. Ha! Oh, that doesn't actually help because I need more board space. Okay, I'm just going to erase it and I'll just do it quick. So we have copper.
So then would copper nitrate be, would it be aqueous then?
Well, that's a good question. We need to look at our
It
solubility.
said it was high.
Yes, very good. So then we have Cu bracket NO3 bracket 2. And then Josh says, well, we need to look at our solubility chart to even find if copper 2 nitrate. So get out your solubility charts. Okay, so when we look on here, so we're dealing with copper 2 nitrate. So here is a nitrate. We go down, it's not in here, so it must be in most, so it's aqueous. Yeah. So thank you for bringing that up. So we can put in aqueous here. Sorry, I kind of ran out of space there.
Could you put CuNO3 before the AG?
Oh yeah, you can have put that compound there too, and that would have been just as fine. Yeah. It doesn't matter what order you write them in. Okay, so now we balance it. So on this side, CUs, AGs, and now keep the NO3 all together. NO and 3, because it's traveling like as a group together, so we don't need to break it up. So anytime you see polyatomics, keep them together. It makes it easier. CUs.
So we're dealing with 3 then and not just 2 anymore?
Pardon me?
We're dealing with 3 elements instead of just 2?
Yes, we are, yeah. Which makes sense because we have X, Y, and Z, right? X, Y, and Z. We're dealing with like kind of 3 groupings. So, we have 1 copper, 1 silver, 1 nitrate. 1 copper, 1 silver, and 2 nitrates. Because it was in the brackets, right? So this whole thing, there was 2 of them. So, to make amends, this is my only thing that's wrong, so I can put a 2 there. So I got 2 nitrates and 2 silvers.
And then we can just put 2 things.
Very good. And then it's all done. Okay? So, that means in this beaker, what am I making now? Okay, you copper nitrate and what else?
And silver maybe?
Silver, come see it. So come and see what the film that's been produced on top of the copper. Yeah, that's silver. That's pure silver. So here, you just pass it around. So as it kind of moves and shakes off, you can see that the silver's coming off. Now, what do we know about copper ions? Copper ions are what color? Have we seen?
I don't know.
They're very blue, right, from that copper 2 sulfate that we've seen. That was blue because of the copper ions. So if we left that for a day, the rest of the solution should be blue. So we'll leave it until you guys come back.
So
and
that when it burns, it turns like green and blue?
yes, that's why when so if we burn this, it would be a bluish green color, right?
It's the same with brass as well, because brass includes copper, so
Yes.
that's why it turns greenish
That's
blue.
right. It's already kind of looking bluish tinge, hey? Like if you
Yeah.
hold it up to something, yeah, it's already getting kind of bluey. And you see the solid that,
Oh, bud.
what?
Just skip this whole thing.
And the solid that's been produced on it is very like shiny, looks very silvery, right? Like it definitely looks like, and it was just made from this, right? And the silver nitrate. It's already, even as it's gone around, gone quite blue.
Maybe it's because it's just moving around, it's kind of shifting.
Well, and the time, the reaction that keeps happening.
Oh, is it?
Right now, I just glued this cube
I'm
to that.
Ankle bone. Yeah.
Has anybody not seen it? The video person? Where's the, there we go. Look, see, oh, you can't hardly see it. Anyone else want to look at it?
Yeah, it's way more blue now.
Yeah, all very sparkly. So we'll leave it for a day to see how much more it reacts. wanna do, let's do another example? Yeah. Let's say we react. Do you guys have room for another example?
Oh, yeah.
Yeah? Okay.
Oh, yeah.
So let's do another one. Let's say we react chlorine gas. So say we have chlorine gas to gas. Okay. And say I react it with sodium iodide in solution. Sodium iodide. So that's Na plus with I minus, and I said it's in solution, so it's aqueous. Why am I putting it so far over? I need to,
So whenever something's soluble, do you always put the aqueous?
when, yeah, from now on when we're doing reactions, reactions happen best when they're in water because there's able to be interaction between the ions. So say we were doing that dating game, but nobody went, on the date. You have to actually go on the date. You have to be in the water because you have to be able to interact with everything. So the question, if it's soluble, do we write it as aqueous? Yes, because when things are in water, that's when they have reactions, the easiest. Yep.
But you don't have to write H2O in the equation.
No, right. Yeah, so when we write aqueous, we're assuming that we dissolved it in water, and that's implying that water is involved.
Does it have to be water? It can be any liquid.
It has to be water. But we don't write, so that, Carson, you asked a good question about actually writing water in, because water actually wouldn't be involved in the reaction, right? Like water isn't a part of this reaction. It's just like the medium in which the reaction took place.
It's
So
just like the setting of like a crime.
exactly. It's like the setting of the crime or of the, they went out for a date to a restaurant. That's where it happened. The restaurant would be the beaker with the water in it. Okay? So because it has to happen at a location, right? Things happen at places, so it's like the setting. Okay? Oh, poor Arvine. He's going to get razzed for like a year now. No, it'll be about a year.
Yeah.
So, okay. So, can you predict the products?
I'm going to say CL. NaCl 2 plus I.
Okay, so how did you think that it would be NaCl?
Because you switched the two that were the same.
Yeah, you switch the two that are of the same kind of category. So iodine and chlorine are both non-metals, right? Or they're both negative ions. So those are the ones that we switch. So then, iodine is going to be all by itself. Sad iodine, it got kicked out.
But there's two of it, isn't there?
Yes,
Why is there two?
because it's in the diatomic table, right? Yeah. And what is iodine when it's by itself at room temperature? Solid. Right? Yeah. And then we end up with sodium chloride. So sodium, its ion is Na plus, and chlorine is Cl minus. So when we crisscross, we get NaCl. Now the setting of this is in water. So is the NaCl going to be still dissolved in water, or is it going to be a solid? So you look at your solubility chart. Okay, so here's Cl. We go down, it's not in this category, so it's got to be most, so aqueous. Or group 1 ions is sodium. We go down, it's not here, so it's most aqueous. Oops. So these types of questions, we're putting together all of our knowledge throughout the whole unit, right? We're doing how to make compounds, knowing what states things are, and now we're balancing. So it's a lot, each question is quite a bit. So now let's balance it. So we have, I'm just going to do the balancing up here because I kind of ran out of room. So we have CLs, NAs, and Is, CLs, NAs, Is. This side I have 2, 1, and 1. This side I have 1, 1, and 2. What shall I do? Is this one really crazy? So let's see here. So my I's, so I need to put a 2 here. So that changes that. Then that changes that one. So then I put a 2 here. And then it changes that. And it changes that. And then I'm done. Where'd you get stuck? You have I2 and CL2? Like when they're by themselves?
Okay, just wait.
I had it right.
Can I ask a question right now?
Sure, so that's now all single replacements, so now try pages 5 and 6 for single replacement.